Welcome to This Is My Code. I'm here today with Cale from Intellify.
Thanks, Mark.
Great to have you here, Cale. Really excited to talk about what Intellify does. Are you able to share some insight into Intellify?
Yeah, sure. So Intellify is a data science and machine learning consulting company that helps companies to achieve competitive advantage through data and algorithms.
So I'm hearing some really strong catchphrases there that lead me to think we're going to be talking about AI and ML today.
Yes, correct.
Absolutely. So what are you doing in that space?
So a lot of the work that we're doing has been in pricing optimization, and it's kind of the use case that we're going to be speaking about today. Pricing optimization is something that is relevant to every single business who has a product.
And what sort of use cases are businesses doing with pricing optimization?
The main one is around pricing perception, and this is about how can organizations improve their price perception in the market.
So would that also include things like looking at which products I should be discounting across a portfolio of products?
Exactly. It should be about trying to figure out what are the ones that you definitely want to be discounting to make sure that customers are getting their best possible value.
I love getting value and I love lower prices, but I also love code. So let's go and have a look at the code we're going to talk through today. I'm not a computer science expert, so I'd love you to walk me through it.
Yeah, sure. So the algorithm we're going to be looking at today is something called particle swarm optimization. And the first step in particle swarm optimization is to make sure that we set the memory of the swarm. So what we're doing here is we're trying to calculate the position that each particle is sitting in. We're also trying to calculate how good each particle is. And then we're also trying to figure out what is the best position inside the swarm as well as each particular particle.
So that's what you're doing here when you're creating these dictionaries of positions and velocities?
Yeah, we're trying to essentially set the memory of each particle as well as the swarm.
Excellent. And then what do you do with those particles?
Yep, so what we try to do is we want to make these particles as random as possible. This is random in terms of the number of particles that we're generating, but also how do they move. So the direction that they're moving in, but also how much they're moving.
Right, so you're setting up that randomness here?
Yes, that's
correct. Is that stochastic?
Yes, correct.
Why would you use stochastic randomization here?
So we're trying to use stochastic process here because the randomness essentially helps the algorithm exploit something called the exploratory exploitation trade-off, which means that we're not always converging to in one direction. We're exploring a whole bunch of new areas.
Right, so you want these things to be moving in different areas of the space that you're exploring.
We don't want the algorithm to be biased, so hence why we want it to be scattered around everywhere.
Yeah, and we hear bias a lot in artificial intelligence and machine learning. So how do you actually calculate the velocities and where these things should be moving?
Yeah, sure. So for the velocities, what we can see here, velocities is just a simple term of where the particle is going to be moving to. There's a couple of different components inside it. The first one is momentum, which is essentially how much each particle is going to be moving by. And it's going to be about how fast that particle is going to be moving as well. The next one is about trying to understand what is the best location around an individual particle, which you can see in this second line here. And the last one is about trying to understand the best possible position inside the total swarm. So this velocity is a combination of that momentum, the best possible location around a particle, but also the best possible location inside the whole swarm, and hence the collective intelligence.
Ah, fantastic. So we've set up some memory for the particles, we've randomized the particles, we've given them the ability to move around in space. How do we actually apply that to the actual problem? I'd love to see some code for that.
Yeah, sure. So that comes into the next section here. So what we're trying to do here is we're trying to essentially calculate something called the fitness function. And the fitness function tells us how well the solution is performing. In this case, we're trying to obviously maximize price perception. And because of this, we want to be obviously discounting the products that essentially impact price perception the most.
Okay, so that's where you take all of this and you actually really apply it to the business problem that you're trying to solve.
And what this fitness function does is it calculates how good each particle is. And because if we understand how good each particle is, it'll help us understand the next best step for each particle.
Excellent. So I've also heard you say that there are multiple particles and they're all moving around in space and they're kind of converging. Are you implying that these particles can communicate with each other?
Yes, correct. So one of the core components of the velocities term is about making sure that each particle is aware of the best possible solution inside the swarm. And because of that, it means that each particle overall will start converging towards that global best solution.
So for people like me who are quite graphical, I'd love to know from you, what would this look like if I was to visualize it?
Yeah, so if you think of it as in a 3D space, so a normal room, this would be a whole bunch of randomly generated particles, and each of them would be moving around very randomly. And what you would find is that each time that particle moves around, we calculate how good is the movement, and then that will feed back to the algorithm. because each time the particle moves, we can calculate how good it is. It's an iterative process where all the particles start to come together, and that is the optimal solution that the swarm has managed to find based on each of the different particles.
So I'd be seeing particles swarming in space and ultimately swirling around and converging into one specific location that's the best fit according to this function for the business problem we're trying to solve.
Exactly.
Fantastic. This is such a great use case. It's one that I hadn't really thought about, so thank you for sharing today.
No worries, you're welcome.
And thank you for joining us on This Is My Code.